Okay. Good afternoon. Sorry. Good evening, dear students. Today we are discussing the properties of phenol. What are the properties of phenol? Properties of phenol. Properties of phenols are two types. One is physical properties. Physical properties. Second one, chemical properties. Chemical properties. First, we are taking physical properties. Physical properties. What are the physical properties of phenol? First point is phenol is colorless, crystalline solid. Crystalline solid. This is a physical state. Physical state. Second one is it is deliquescent. It is deliquescent. What is deliquescent? It is absorb the water. Absorb the water and converted into liquid states. If you take here Harpic must be contain one of the ingredient phenol. So what is the uses of phenol? Phenol is used as a disinfectant or antiseptic. Okay. So how it is useful here? It is used as antiseptic or disinfectant. Okay. So third one, solubility. Solubility. Phenol soluble, slightly soluble in water. Phenol slightly soluble in water. Why it is slightly soluble in water? What is the major point here? Due to formation of intermolecular hydrogen bond. Formation of intermolecular hydrogen bond with water. If you have any doubt, observe this structure. Phenol, water. Water, HOH. Another phenol, OH. Observe here. It is highest electronegative, it is positive. So it creates negative pole, positive pole. Here positive pole, negative pole, positive pole. Here negative pole, positive pole. Hydrogen bond formed between positively charged hydrogen atom and high electronegativity of same molecular different molecule. Here also same. Due to the formation of intermolecular hydrogen bond, it is slightly soluble in water. Okay, it is slightly soluble in water. Next, another one, boiling point. Phenol has high boiling point high boiling point than hydrocarbon, halogen, and ethers of comparable masses. I repeat, phenol has high boiling point than hydrocarbon, means alkane. Halogen means either chlorobenzene or bromobenzene or fluorobenzene or iodobenzene. And ether with comparable masses. Means if the phenol and hydrocarbon, halogens and ether having same molecular masses, then after their boiling point is more in phenol than compared to remaining. Why phenol has highest boiling point? What is the reason? Due to the formation of intermolecular hydrogen bond. Observe the structure. OH, here another phenol, OH. Compared to these two, it is electronegative, it is positive. Negative pole, positive pole. Between these two, intermolecular hydrogen bond form. Due to the formation of intermolecular hydrogen bond, phenol has highest boiling point. Okay, these are the physical properties of phenol. Last one, very important. When phenol exposed to air, when phenol exposed to air, it means it is undergoes oxidation in the presence of light, gives what is the product? Here oxygen is added, hydrogen is removed, so gives what is the product? Observe the product. When hydrogen is removed, this lone pair of electron bond involved here, so gives this compound. Here also oxygen added, it is coming from air. What is the name of this compound? Its name is quinone. Quinone. Due to the formation of quinone, it exhibits pink color. This is the one of the identification test for phenol. That's why nowadays we are using color phenols. Color phenols. Why phenol is colored? Actually, original phenol is colorless crystalline solid. When it is exposed to air in the presence of light, phenol converted into quinone. That's why it is exhibit pink color. Okay, note down firstly. Yes, double bonded oxygen. Deliquescent means it absorbs the, or it is ready to convert it into liquid. How it is absorbed the water molecule and converted into liquid states. Okay. Now we are taking chemical properties. What are the chemical properties of phenol? Chemical properties of phenol. Chemical properties of phenol. Here first one, reaction of hydrogen. Reaction of hydrogen atom of OH group. OH group. Second one, reaction due to phenolic OH group. Phenolic OH group. Third one, reaction due to S becoming liquid. Good. Reaction due to aryl path or benzene ring. Benzene ring or aryl path. Fourth one, some typical reactions. Some typical reactions. Okay. Now one by one we are taking. What is the first one? Reactions of hydrogen atom of OH group. Okay, it is simply says breaking of OH bond. Breaking of OH bond. What are the breaking of OH bond reaction? Here first one with sodium. Phenol react with sodium. Gives what is the product? Here hydrogen displaced by sodium to form sodium phenoxide plus the mole of hydrogen. I repeat, phenol react with sodium metal gives rise to sodium phenoxide with liberation of hydrogen gas. This reaction indicates that phenol is acidic. Phenol is acidic. Second one, with NaOH, phenol is acid. React with base, that is NaOH, gives rise to what is the product? Here hydrogen OH group converted into water. Remaining to form sodium phenoxide. This reaction also indicates acidic nature of phenol. That's third one. With Na2CO3 or NaHCO3. Phenol with the sodium carbonate or sodium bicarbonate, no reaction. This reaction indicates that phenol less acidic. Phenols are less acidic than carboxylic acid. Okay, note down fastly. Okay, as per your track, acidic nature of phenol explained the tomorrow class, means Monday class. After that, we are discussing reaction due to phenolic OH group. So second one, note down reaction due to phenolic OH group. Reaction due to phenolic OH group. Here, first one, reaction with zinc dust. Reaction with zinc dust. Phenol react with zinc. Gives rise to what is the product. Here, zinc and oxygen converted into zinc oxide. What is the remaining? Benzene is formed. Okay. Phenol converted into benzene. What is the similarity between phenol and benzene? Both are aromatic compound. Means they retain aromaticity. Here important point. In benzene ring, every carbon undergoes sp2 hybridization due to the presence of double bond, but oxygen undergoes sp3 hybridization. But in benzene, every carbon undergoes sp2 hybridization due to the presence of double bond. Okay. So here, what is the difference between phenol and benzene? Similarities. Both are aromatic compound. Both are at retain benzene ring. Okay. But difference in the hybridization of oxygen in phenol. Here, hybridization of oxygen is sp3. Here, sp3 hybridization is option. Similarity in benzene nucleus, every carbon undergoes sp2 hybridization. Okay. Another one. This method is useful for preparation of benzene. Okay. Next to second one. Reaction with PCl5. Reaction with PCl5, phosphorus pentachloride. Phenol react with phosphorus pentachloride. PCl5 gives what is the product? Here hydrogen react with chlorine HCl form, that is byproduct. That's good. Next another one. One chlorine attack on the benzene ring by displaceable oxygen. This oxygen react with phosphorus and 3 chlorines. So gives what is the product? Chlorobenzene. Chlorobenzene. Byproducts EOCl. Yes, good. Here, one of the interesting point is if chlorobenzene react with sodium phenoxide, sodium phenoxide, here chlorine react with sodium to form NaCl. What is the remaining? To form ether. pH means benzene ring. So it form ether. Actually, in this reaction, up to this one enough. Phenol react with phosphorus pentachloride to form chlorobenzene. Okay. The next one, very important. Reaction with ferric chloride. First one, it is useful for identification of phenol. Useful for identification of phenols. How, sir? Due to the formation of color. Which color? Violet color. Observe this structure. Phenol C6H5OH react with ferric chloride. Here, hydrogen react with chlorine gives rise to HCl. How many chlorine? 3. Here 3. These 3 hydrogen coming from phenol. So iron come react with 3 moles of phenoxide gives OC6H5 taken thrice. If you have any confusion, observe the color changes. Its color is violet color. It is one of the complex. Okay? I repeat. Reaction with ferric chloride is useful for identification of phenol or separation of phenol from alcohol. How? Phenol react with ferric chloride. This is neutral ferric chloride. Gives violet color. Okay? Last reaction in the second reaction due to phenolic OH group. That is a reaction with ammonia. What is the name of this reaction? Bucherer reaction. Bucherer. Bucherer reaction. Here observe the reaction. Phenol react with ammonia. Phenol react with ammonia in the presence of anhydrous zinc chloride. Anhydrous zinc chloride at 300 degrees Celsius gives what is the product. Observe here, OH group, here one nitrogen converted into water. What is the remaining? NH2 group bonded to benzene ring. What is the name of this compound? Its name is aniline or aminobenzene. Aniline or aminobenzene. Okay? Is it clear? Okay. Next one. Very, very important. Third model. Reaction due to reaction due to benzene ring. Reaction due to benzene ring. Here, observe the structure. Okay. Here, oxygen has positive mesomeric effect. What is positive mesomeric effect? The group which has tendency to increase the electron density for resting molecule. How, sir? Here, due to the presence of lone pair of electron and oxygen, it is ready to donate electron pair between carbon and oxygen. If this happens, this pi bond electron shifted toward the ortho position. So it gives what is the structure? OH double bond with negative charge. Negative charge indicate electron density increases at ortho position. How it is possible? Due to the presence of OH group. Next continuation. If these pi bond electrons shifted to here, pi bond electron increase the at para position. Here positive charge. So electron density increases at para position. Okay. I repeat. In phenol, OH group release the electrons by positive mesomeric effect and increase the electron density, that is pi electron density at ortho position and para position. Therefore, electrophilic substitutional reaction, ESR, electrophilic substitutional reaction occur అటు ఆర్తో అండ్ para position. Okay, next another one. Electrophilic substitutional reaction of phenol greater than benzene. Why phenol has highest electrophilic substitutional reaction than benzene? What is the difference between benzene and phenol? Here in phenol, OH group is present, plus MFet group. Here plus MFet group offset. That's why it is increased the electron density at ortho and para position. Here no increase the electron density at ortho and para position. That's why electrophilic substitutional reaction of phenol is greater than benzene. Here, what is electrophilic substitutional reaction? In the reaction, atom or group is substituted by electrophile. Then the reaction is called electrophilic substitutional reactions. Which are undergoes electrophilic substitutional reaction? Observe key point. One is benzene. In first year, benzene. In second year, chlorobenzene. Another one, phenol. Next, another one, anisole, that is methoxybenzene, is one type of ether. Last one, phenol, sorry, aniline. I repeat, benzene, chlorobenzene, phenol, anisole and aniline undergoes electrophilic substitutional reaction. Okay, what are the examples of electrophilic substitutional reaction? Electrophilic substitutional reactions are halogenation, nitration, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation. Okay, we are taking name of the reaction electrophile. In halogenation, electrophile is halogen X plus. In nitration, electrophile is NO2 plus. In sulfonation, electrophile is neutral molecule, that is a sulfur oxide molecule. In alkylation, that is Friedel-Crafts alkylation, electrophile is alkyl group R plus. In a Friedel-Crafts acylation reaction, electrophile is RCO plus. And the carbon pass two charge. So these are the electrophiles. Okay. Here, due to the plus sum effect of OH group in the phenol, it is increase the electron density at ortho and para position. Hence, in electrophilic substitutional reaction, electrophile attack at ortho position as well as para position. Among ortho and para substituted compound, para compound is more stable, that is major compound. Ortho compound is minor compound. Okay, now we are taking one by one equation. First one, as per your material, we are taking nitration. First one, nitration. Actually here electrophile. What is electrophile? Electrophile equal to NO2 plus. Okay. Here reagent is, what is the reagent? Nitration mixture. Actually here we are taking nitric acid. Okay, first with dilute nitric acid. With dilute nitric acid. Observe, phenol react with dilute nitric acid. Dilute nitric acid at a room temperature, that is 298 Kelvin, gives what is the product? At ortho position hydrogen, this hydrogen, one oxygen, here one oxygen converted into water. What is the remaining? NO2 group. Here NO2 group bonded to phenol. What is the name of this compound? NO2 group at ortho position. Or if you take a UPS name, 2-nitrophenol or orthonitrophenol. This is phenol. And also OH group increase electron density to para position. Hence, here hydrogen, oxygen converted to water. That's why here it gives a mixture of ortho compound as well as para compound. So what is the name of this compound? 1, 2, 3, 4. 4-nitrophenol. 4-nitrophenol or para-nitrophenol. I repeat, phenol react with dilute nitric acid at room temperature. Two types of possibilities are there. What is the two possibilities? At ortho position, hydrogen in nitric acid, hydrogen and oxygen converted into water. It means hydrogen substituted by NO2 group. So it gives orthonitrophenol. Orthonitrophenol. This is minor. It is minor. Less quantity obtained. And also at para position, hydrogen in the nitric acid, hydrogen and oxygen converted into water. Possibilities. Here hydrogen replaced by NO2 group, it gives 4-nitrophenol or para-nitrophenol. Here interesting point, orthonitrophenol and para-nitrophenol, both are separated by steam distillation. It is important. How, sir? Para-nitrophenol was able to the formation of intermolecular hydrogen bond. That's why it is less volatile. Orthonitrophenol was able to formation of intramolecular hydrogen bond. Hence it is more volatile. Means it is evaporate with water or steam. Hence both are separated by steam distillation process. Another one, if we take acidic nature concept, here NO2 group is electron withdrawing group. Electron withdrawing group directly proportional to acidic nature. So here NO2 group is electron withdrawing group at the para position. So it is more acidic. Next to ortho, next to phenol. Important order. What is the correct order of acidic nature of phenol, orthonitrophenol and para-nitrophenol? Para-nitrophenol is most acidic than ortho-nitrophenol. Ortho-nitrophenol is most acidic than phenol. I think you have wondered why ortho and para-nitrophenols are more acidic than phenol. In ortho and para-nitrophenol, electron withdrawing group, that is NO2 group, is present. Okay, sir, why para-nitrophenol is most acidic than ortho-nitrophenol? In para-nitrophenol, here NO2 group stabilize the phenoxide ion. Phenoxide ion means it is ready to donate the proton. Okay, so your acidic nature is mainly depends upon stability of phenoxide. Okay, here acidic nature explain various methods. One is, one by one listen. Acidic nature directly proportional to withdrawing groups. Acidic nature directly proportional to acid dissociation constant. Acidic nature inversely proportional to electron donating group. Acidic nature inversely proportional to pKa. Okay. So compared to these three, para-nitrophenol most acidic, next ortho-nitrophenol, next phenol. Okay, if you have any confusion, note down here. Acidic nature of phenol directly proportional to electron withdrawing group. It is directly proportional to Ka of acid, that is phenol. It is directly inversely proportional to pKa. It is inversely proportional to electron donating groups. Very, 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 very important. Acidic nature directly proportional to minus I effect, negative inductive effect. Observe. Is it clear? With dilute acids, ortho and para-nitrophenol form. Now we are taking concentrated nitric acid. Concentrated nitric acid. With concentrated nitric acid. Okay, phenol react with concentrated nitric acid. Phenol react with concentrated nitric acid. Here OH group increase the electron density at ortho position and para position. Ortho and para positions of hydrogens in nitric acid, 3 hydrogen and 3 oxygen converted into 3 moles of water. Here hydrogen, here hydrogen, here hydrogen. These hydrogen, here these 3 hydrogen and 3 oxygen converted into water. What is the remaining? This is phenol. React with concentrated nitric acid, gives rise to NO2 group attack at second carbon and also fourth carbon and fifth carbon. Its common name picric acid. Picric acid. Or if you take IU base name, what is IU base name? 2, 4, 6 trinitrophenol. Okay. Recently I told you phenol does not react with sodium carbonate and sodium bicarbonate, but only picric acid react with sodium bicarbonate to liberate carbon dioxide. This is indicate that it is strongest acid than remaining acids. That is phenol or nitrophenol or dinitrophenol, etc. But here, which of the following is acid but do not contain COOH group? Picric acid. Okay, if you take picric acid, paranitrophenol and orthonitrophenol and phenol, which is most acidic? Here number of electron withdrawing groups 3. Electron withdrawing group directly proportional to acidic nature of phenol. So first most acidic, next paranitrophenol, next orthonitrophenol, next to phenol. Okay. In this process, picric acid formation is poor. That's why we are taking another process. What is the another process? Listen. Phenol first it react with sulfuric acid. Phenol react with sulfuric acid at 375 Kelvin. Here hydrogen, here also hydrogen react with 2 hydrogen and 2 oxygen gives rise to removal of 2 moles of water. Gives what is the product? Sulfonic acid group bonded to phenol. Observe the structure of phenol. What is the name of this compound? 1, 2, 3, 4, 5, 6. 4 hydroxy benzene 1, 3 1, 3 disulfonic acid. Our material question. Phenol react with sulfuric acid gives X. What is the U base name of X? 4 hydroxy benzene 1, 3 disulfonic acid. I think you have one doubt. Sir, why phenol first convert into sulfonic acid? What happened here? Actually, phenol group increase or activate the benzene ring. So the activity of phenol is slowed down by the formation of sulfonic acid. Okay, this sulfonic acid react with concentrated nitric acid. Concentrated nitric acid. Here, it gives rise to picric acid. I think you have won that one. I know. 1 minute. Sir, how sulfonic acid replaced by nitric acid? Observe here bond. Carbon to sulfur, carbon to sulfur. Here, carbon to nitrogen, carbon to nitrogen, carbon to nitrogen. Here, carbon to sulfur bond easily removed. Why, sir? Here, sulfur has large atomic size, nitrogen has small atomic size. That's why here carbon to sulfur bond is weak than compared to carbon to nitrogen. Hence, SO3H group easily removed by nitric acid to form picric acid. Expected question. Phenol react with sulfuric acid gives rise to X. X react with concentrated nitric acid gives rise to Y. How much percentage of Y? That is 90% picric acid. Okay. This is the nitration reaction. Next, second one. Halogenation. Halogenation. Nitration means NO2 group attack at ortho para position. Halogenation means halogen attack at ortho para position. Here also two reactions. One is with bromine in carbon disulfide. This is weak solvent, or carbon tetrachloride or chloroform. Here we are taking weak solvent. Okay, phenol. React with bromine in the presence of carbon disulfide. Important equation. It is very, very, very important. First priority, second priority. Okay, here hydrogen substituted by bromine gives rise to what is the product? Bromine attack at ortho position. So what is the name of this compound? 2-bromophenol, or common name orthobromophenol. It is minor. Another possibility, at para position hydrogen replaced by bromine. B.R bonded to benzene ring. So what is the name of this compound? 1, 2, 3, 4, 5, 6. 4-bromophenol or para-bromophenol. It is major compound. Major. Okay. Next one, D with bromine in water. Water is more polar solvent, weak solvent. Okay. Phenol react with bromine in water. Here, ortho position hydrogens, para position hydrogens react with 3 bromine, gives rise to 3 HBr. It means at ortho and para position hydrogen substituted by bromine, that is electrophile, gives what is the product? OH. Remaining bromine, bromine, bromine. Its name 1, 2, 3, 4, 5, 6. 2, 4, 6 tribromo phenol. Pakka question. Bromine in water gives 2,4,6 tribromophenol. Bromine with disulfide, carbon disulfide. Phenol gives orthobromophenol and parabromophenol. Among these two, it is more stable. As per your textbook, these two reactions in the electrophilic substitutional reactions. If you want remaining, I will explain through the flow chart. So observe the flow chart. Only neat level. Phenol, react with sulfuric acid. Phenol react with sulfuric acid. Here at different temperatures, at 292, 292, 295 Kelvin. At ortho position hydrogen, here hydrogen, one oxygen removed as water. What is the remaining? OH. SO3H. What is the name? 1, 2. 2-hydroxy benzene sulfonic acid. I repeat, phenol react with sulfuric acid 290 to 295 Kelvin, gives rise to 2-hydroxy benzene sulfonic acid. Simple orthoisomer. If you take, that is 375 Kelvin. At 375 Kelvin, in para position, hydrogen, here hydrogen, one oxygen converted into water. What is the remaining? OH, SO3H. Its name 1, 2, 3, 4. 4-hydroxy benzene sulfonic acid. Okay. Next, another one. If it is undergoes Friedel-Crafts alkylation, it is react with methyl chloride in the presence of anhydrous AlCl3. Anhydrous AlCl3. What is the name of this reaction? Friedel-Crafts alkylation reaction. Gives what is the product? Here, at ortho position hydrogen, here chlorine removed as HCl. It means methyl group attack at ortho position, remaining as it is. This is orthocresol minor plus another possibility. OH group at CH3 group at a para position. That is indicate paracresol. It is major. Okay. These are the examples of electrophilic substitutional reactions or reaction due to benzene ring. Yes, I know. Time up.